Hi, welcome to our Organic Chemistry Simplified series. In today's video, we dive into what organic chemistry is really all about. So grab your pens, grab your books, and let's have fun. What is organic chemistry? Now, organic chemistry, let us first of all break down the word organic. Organic simply refers to things that come from living organisms. So things that come from things like plants, animals, all the things that come from living organisms are always referred to as what? Organic. So organic chemistry is simply the chemistry of what? Living organisms. So it's simply the chemistry of living organisms. Now, what is really organic chemistry? Now, organic chemistry is the study of all the compounds of carbon, with exceptions to the oxides of carbon, trioxocarbonates, the metallic carbides, and the cyanosalts of carbon. I repeat myself again. Organic chemistry is the study of all the compounds of carbon, with exceptions to the oxides of carbon, trioxocarbonate 4 of carbons, your metallic carbides, and your cyanosalts. I know this is a handful, but another simpler definition is organic chemistry is the study of carbon, hydrogen, and their derivatives. But in exam cases, it is more preferably to use the first definition. So organic chemistry, you say, is the study of all the compounds of carbons, with exceptions to the oxides of carbon. Now, why is oxides of carbon an exception? For example, if you have your carbon 4 oxide, this is not an organic compound. So that is why oxides of carbons are not are exceptions to compounds that we refer to organic compounds. You also have your carbon monoxide. This is your carbon monoxide. This is also not an organic compound. Now they say the oxides of carbon, your trioxocarbonate 4, your trioxocarbonate 4. These are your trioxocarbonate 4. For example, if you have your hydrogen trioxocarbonate 4, this is not an organic compound. And that is why this is an exception to the definition of organic chemistry. We also have your metallic carbides and your cyanosalts of carbon. Now, you see things that come from plants, animals. You see the food you eat, the clothes you are wearing right now are all products of organic compounds. You see, when we refer to organic compounds or organic chemistry, we are always thinking about things that come from living organisms. But scientists over the years have been able to model things that come from living organisms in the laboratory. And that is why organic chemistry is an important subject of interest. Now, organic compounds, or everything about organic compounds, revolves around molecules that have carbons. So everything about your organic chemistry revolves around molecules that have carbon. You see, from the definition, we say the organic chemistry is the study of all the compounds of carbons with their exceptions, which we listed out. Now, why is carbon important in organic chemistry? Or why is carbon the backbone of organic chemistry? There are a few reasons why I'll be listing them out. The first reason why carbon is important in organic chemistry is that due to the exceptional ability of carbon atoms to catenate. The first one is due to the exceptional ability of carbon atoms to catenate. Now, brings us to the question, what is catenation? Catenation is the ability of atoms to combine with one another. So, but let us now bring it to carbon now. Catenation is the ability of carbon atoms to combine with one another to form ringed, branched, and linear chains. It will either form linear chains, branched chains, or ring structures. So catenation is the ability of carbon atoms to combine with one another to form linear chains, branched chains, and ringed structures. Now, what this is trying to say is, in all the elements, there are only few elements that can catenate. Elements like your silicon, your boron, your phosphorus. But carbon is the only atom that is, or element that is very versatile in catenation. And that is why it is important what in organic chemistry. So we said, why is carbon important in organic chemistry? We say, one, due to the exceptional ability of carbon atoms to what? Catenate. What does it mean? You see, in your organic chemistry, you will tend to see things of this nature. This is a linear chain. Carbon atoms can also form what? Ring structure. And they can also form what? Branched chains. This is what the first one is trying to say. Is due to the exceptional ability of carbon atoms to catenate. The second one is the ease with which carbon combines with hydrogen, oxygen, nitrogen, and halogens. Repeat myself again. You see the ease with which carbon atoms combine with what? Hydrogen, oxygen, nitrogen, and your halogens. Your halogens like your chlorine, your fluorine, your iodine, and the rest. So your chlorine, you don't write them as single atoms, they are always diatomic. So these are what the halogens we are talking about. And they are always used, or let's leave that one when we move to other videos, we'll discuss about them. Now, you see the ease with which carbon combines with what? Oxygen, hydrogen, nitrogen, and what? The halogens. That is the second reason why carbon is important in what? Organic chemistry. The third one is the ability of carbon atoms to form single, double, or triple bonds. I repeat myself again. The ability of carbon atoms to form single, double, or triple bonds. You see, in organic chemistry, you will tend to see things of this nature. You will see carbon double bonded. This is a single bond, and this is a double bond. So the ease with which carbon atoms, not every element not every element combines easily or forms single, double, and what? Triple bond. Now, why is that? It's because what? Carbon atom is tetravalent, and that's what gives it this nature or this ability to form single, double, and what? Triple bonds. The next one is the different arrangement of carbon atoms within a molecule produces a variety of compounds. I repeat myself again, don't worry, I will explain it. It's a different arrangement of carbon atoms within a molecule produces a variety of compounds. That is the fourth reason, the fourth reason why carbon is important in organic chemistry. They say different arrangement of carbon atoms within a molecule produces a variety of compounds. Now, if you don't want to write all this, I'll say, you can say the ability of carbon to what? The ability of carbon to form isomers. Don't worry, continue watching this series, or if you are enjoying this video, you can also like, share, and subscribe, because in subsequent series, we'll discuss about isomerism. So you will understand what this means. It's the ability of carbon atoms to what? To form isomers. The ability of carbon atoms to form isomers. You see this? You see this? This is the different arrangement. Now we have only 3 carbon here. We have 3 carbons here, but they are different compounds. So the different arrangement of carbon atoms within a molecule produces a variety of compounds. So this compound can form a different thing in organic chemistry, and this compound can also form a different thing in organic chemistry, notwithstanding the fact that we have only 3 carbon atoms. And that is the reason why carbon is very important in organic chemistry. So next, we'll be looking at the general characteristics of organic compounds. That means what can you always find in every organic compound you come across. This is very important because as you are learning deep or you are going deeper into organic chemistry, you need to know their general characteristics. We'll also be looking at saturated versus unsaturated organic compounds. But first of all, let's start with the general characteristics of organic compounds. The first characteristic is that organic compounds are highly flammable or inflammable. Flammable and inflammable they mean the same thing. So organic compounds are highly flammable or inflammable. What it means is organic compounds can be easily set on fire. You see, for example, like your fuel, your petrol, your kerosene, your diesel are all products of organic compounds. So that means they are highly what? Flammable or inflammable. So every organic compound you come across are highly flammable or inflammable. Even the clothes we wear, they are highly flammable. You see, so they are products of organic compounds. So we say they are products of organic chemistry, as we said before. So that means they are what? Highly flammable or inflammable. The second one is organic compounds have low melting and low boiling points. Organic compounds have low melting and low boiling points. Now, this is due to the weak intermolecular forces that are found in organic compounds. So, the second one is the what? They have low melting and low boiling point. Why? Because of the weak intermolecular forces that are found in organic compound. And that weak intermolecular force is referred to as your what? Van der Waals forces. Your Van der Waals force. So due to Van der Waals forces that are in organic compounds, they have low melting and low boiling points. Now, why? In some cases, you will see them high, but relative to inorganic compounds, they have low melting and low boiling points. The next one is organic compounds vaporize easily. Organic compounds vaporize easily. You see, like your petrol, if you have your petrol or your fuel and you open it and you leave it open for some time, you see that, or maybe if a petrol pours on your hand, you see that your body becomes cool after some time. It vaporizes very easy. That is why when you buy your fuel or you buy your petrol, you don't open it. Especially we that are in Africa or we that are in Nigeria. You see, this part of this world, we use petrol, we use fuel as our source of energy for transportation. So fuel and petrol vaporize easily. And that is why organic compounds are said to what? Vaporize easily. The fourth one is organic compounds do not conduct electricity. Organic compounds do not conduct electricity. Now, why is that? This is due to the absence of mobile ions. So, due to the absence of mobile ions in organic compounds, they do not what? Conduct electricity. They lack mobile ions. So organic compounds do not what? Conduct electricity. The fifth one is organic compounds are insoluble in water. That means they do not dissolve in water. Organic compounds are insoluble in water. For example, your palm oil, your kerosene, whenever you pour palm oil to be specific inside water, you see that it does not dissolve. It's always at the top floating. So that's your palm oil is now telling you that it's a product of what? Organic compound. So that means it is what? It is insoluble in water. But note, there are organic compounds that are soluble in water. Example, we have your alcohol. We have alcohol, we have your ethanoic acid, or let's say your carboxylic acids instead. Carboxylic acids, also your glucose. You see, all of these are organic compounds, but they are soluble. They are also more, but you see, they are soluble in water, but they are organic compounds. Why? Because of the presence of hydroxyl group. Don't worry if you don't understand what it means now. Subsequently, we'll start discussing solely on these groups and you will understand them better. But due to the presence of hydroxyl group, your hydroxyl group is your OH group. So this is your hydroxyl group. So due to the presence of hydroxyl group in these compounds, they are able to form hydrogen bonds with water. So due to the fact that they have hydroxyl group, you know your water is H2O. So they are able to form hydrogen bonds with water and therefore they are soluble in water. So those are the general characteristics of what? Organic compounds. If you don't understand any parts, you can just take it back a little bit, watch it again, and you will understand what we are talking about. Now, we'll be discussing about saturated versus unsaturated compounds. Saturated versus unsaturated compounds. First of all, let's start with saturated compounds. Now, organic compounds that containing atoms joined together by only single covalent bonds are referred to as what? Your saturated organic compounds. I repeat it again. Saturated organic compounds are compounds that contain single covalent bonds. Let's use that. Saturated organic compounds are organic compounds that contain single covalent bond. Example, your alkanes. Your alkanes. Don't worry, we'll discuss extensively on these groups. So just know that your alkanes are saturated organic compounds because they are joined together by what? Single covalent bond. So now, let's know a few alkanes. Now, alkanes is actually a family. So the first alkane we can start with is your methane. This is your methane. See, it is joined by what? Single covalent bond. And that is why it is referred to as what? Your saturated organic compound. Another one, let me write it here. This is your methane. Another one is your ethane. Your ethane is another what? This is ethane. See, this is ethane, and this is it is joined by only what? You see, the carbon atoms are joined by single covalent bonds, and that is why it is what? A saturated organic compound. Another way to look at it is this. You see that in this carbon there is no space, so it shows that everywhere is full. When something is saturated, meaning it is full. So this compound is full. There is no space for anything to add up here, and that is why it is a saturated. You know, carbon is tetravalent, so it is full. 1, 2, 3, 4. There is no space here, and since there is no space here, it is referred to as what? Saturated organic compounds. Now, what do we now call unsaturated organic compounds? Now, organic compounds that contain carbon atoms joined by double or triple covalent bonds are unsaturated organic compounds. I'll repeat myself again. Organic compounds that contain carbon atoms joined by or triple covalent bonds are said to be what? Unsaturated organic compounds. Unsaturated organic compound. Examples are your alkenes. Your alkenes and alkynes. Your alkenes and alkynes are what? Your unsaturated organic compounds. Your alkenes and your alkynes are unsaturated organic compounds. So let's give a few examples. Let's start with your alkene. Your alkene, you can have your ethene. You can have your ethene. Let's see. Don't worry, you can still put the hydrogen here regardless. But you see there is space here. There is space here, and that is why it is what? An unsaturated. Or best way to look at it, it contains a double bond, and therefore it is an unsaturated compound. So organic compounds where the carbon atoms are joined by double or triple covalent bonds are said to be unsaturated. This is your ethene. Ethene, that means it is from the alkene family. Now another one is, see, this is a triple bond. Hydrogen and what? Hydrogen. You see, it is complete. 1, 2, 3, 4. So that means 4. This carbon is complete. 1, 2, 3, 4. And therefore, this carbon is complete. So therefore, it is what? This is your ethyne. Ethyne. This is ethyne. And therefore, it is what? An unsaturated compound. And lastly, we have compounds. Now we have discussed about saturated and unsaturated. There's also another category of unsaturated compounds. Now, compounds that contain double or triple bonds between a carbon atom and another atom and an atom of another element are referred to as what? unsaturated organic compounds. I repeat myself again, compounds that contain double or triple covalent bonds between a carbon atom and the atom of another element is referred to as what? Unsaturated organic compound. So your unsaturated therefore means that it can be between two carbon atoms, and it can also be between a carbon atom and the atom of another element. For example, when we have this is double bonded to O, and this is H, this is H, H, H. This is what we call ethanol. You see that the double bond is not between two carbon atoms, it is between the carbon atom and the atom of another element, which is oxygen here. And that is why this is also what? An unsaturated organic compound. Another example is your ethanonitride. Ethanonitride. Now this is, we have carbon here, 1, 2, 3, triple bonded to what? Nitrogen. And we have hydrogen, hydrogen, and hydrogen. And this is what we call ethanonitride. Ethanonitride. This is an ethanonitride. And that is why this is, because it is triple bonded to the atom of another element. And that is why this is also referred to as what? An unsaturated organic compound. Now, this is where we'll be stopping in this video. Organic chemistry is a subject that builds up. So it adds up. This knowledge might look very simple now, but it will help you as you go further. So don't cram, try and understand each concept we have dealt with and just understand them, because in subsequent videos, everything will begin to make sense. So just understand them, don't cram, just know that organic chemistry adds up and it is a very interesting subject. So see you in the next video.